Looks like someone's getting ready for some serious chemistry. A whole stack of notes on the periodic table.
Yeah, don't worry.
You bet.
We're here to help you unpack it all.
Exactly. We'll dive deep and make sure you really get it.
Not just memorize it, right?
Exactly.
Because that's no fun.
It's about understanding the why behind it all.
Okay, so you sent us some textbook excerpts on the periodic table.
Right.
So
It's like
what is the periodic table? Like,
It's a way of organizing all the known elements,
okay.
the building blocks of everything in the universe,
Uh-huh.
and we organize those based on their properties.
I see.
Think of it like a giant family portrait.
Okay.
Right. But instead of, those goofy grins,
Yeah.
it's protons, neutrons, and electrons.
Protons, neutrons.
Right.
Okay, I'm looking at this source material, and
Yeah.
I'm seeing like rows and columns.
Absolutely.
Like a spreadsheet almost.
That's a great way to think about it.
What's the deal with that?
So those rows,
They're called periods,
okay,
and they show how many electron shells an element has.
electron shells.
Right, like energy levels for electrons.
Gotcha.
So further out from the nucleus as you go down the table.
Okay.
And the columns or groups,
Yeah.
those are elements that have very similar personalities
Okay.
because they have the same number of valence electrons.
Valence electron.
Right.
Okay, remind me what those are again.
Those are the ones on the outermost shell that do all the reacting.
Oh, so they're the ones that determine how.
They're the social butterflies.
Yeah.
They're the ones interacting with other elements.
Okay, cool.
Yeah.
Now I'm also seeing this word blocks in here.
Yeah, blocks are interesting.
They sound kind of mysterious.
They are.
What are they all about?
So those blocks, we've got SP, DO, and S.
SPD.
And they tell us
Okay.
about the shapes of the orbitals that those valence electrons are hanging out in.
Okay.
So think of orbitals like electron apartments.
Electron apartments. I like that.
And the shape of that apartment affects
Yeah.
how easily those electrons can interact with other atoms.
So it determines like how reactive it is. And
It's one reason why some elements are metals and others aren't.
Gotcha. Okay.
Yeah.
So it's not just random
No,
where they are on the table.
not at all.
Okay, cool.
It's very intentional.
So tell me about these atomic numbers.
Yeah.
And symbols.
Yeah, so the atomic number is really important
Okay.
because it tells you the number of protons in an atom.
Okay.
And that's what defines an element.
So that's like its ID number.
Exactly. It's fingerprint.
Okay.
And if you change that proton count,
Yeah.
you change the element entirely.
Oh, wow.
It's no longer the same.
Okay.
So symbols are just shorthand.
Gotcha.
Some of them are a little odd, like Fe for iron.
Fe for iron.
Yeah.
That doesn't make any sense.
Well, it comes from the Latin word ferrum.
Oh, so it's like
Yeah, so there's a lot of history embedded.
a secret code.
Yeah, exactly.
But based on ancient languages.
Exactly.
That's really cool.
Yeah.
So there's more to this detective's toolkit.
Oh, there's so much more.
Right.
Absolutely.
Because I'm also seeing periodic trends mentioned in here.
Ah, yes.
What's that about?
So periodic trends.
Okay.
It's all about predictability.
Okay.
You know, elements' properties change in a predictable way
Okay.
as you move across or down the table.
Gotcha.
For example,
Yeah.
atomic radius.
Okay.
That's the size of the atom.
Huh?
Decreases as you move across a row,
Okay.
but increases as you go down a column.
Wait, so the trend reverses.
It does.
Why is that?
Because as you go down a column, you're adding more electron shells.
Right.
So those outer electrons
Yeah.
are further from the nucleus
Okay.
and not held as tightly.
So they're not.
It's like adding layers to a cake.
Okay.
The frosting on top
Gotcha.
is further from the center.
The frosting is further from the center.
Yeah, exactly. Okay, that makes sense.
Right.
What other trends should we be aware of?
So another important one is ionization energy.
Okay.
And that's basically how much energy it takes to rip an electron off an atom.
Okay.
And that increases across a row,
Uh-huh.
but decreases down a column.
Okay.
And this is crucial for understanding things like battery technology.
Raise, yeah.
Because elements with low ionization energy,
Okay.
they give up electrons easily,
Oh, okay.
making them good for creating electrical current.
So that's why lithium's so popular for batteries.
Exactly. Lithium is way down on the left side of the table.
Uh-huh.
Low ionization energy.
Gotcha.
Gives up electrons easily.
That makes a lot of sense.
Yeah.
Okay, let's talk about some of these must-know element groups.
Let's do it.
Starting with alkali metals.
Oh, yeah.
They sound kind of wild.
Alkali metals.
Yeah.
They're the party animals of the periodic table.
Okay.
Super reactive, especially with water.
Oh, really?
You drop sodium in water.
Yeah.
And boom.
You get an explosion of hydrogen gas.
So maybe not the best for a backyard
Right.
science experiment.
Unless you're very careful and know what you're doing.
Yeah. I think I'll leave that to the professionals.
Yeah.
Okay.
But it all has to do with that single
Yeah.
lonely valence electron they're just desperate to get rid of.
They just want to get rid of it.
They're like, here you go, take it.
Okay.
Yeah.
So that's the alkali metals, the givers.
The givers.
Now, what about halogens?
Halogens are the opposite.
Okay.
They're electron grabbers
Okay.
because they're one electron away
Yeah.
from a full outer shell.
Uh.
And they're like, give me, give me, give me.
They want it.
They want it.
Okay.
Fluorine.
Yeah.
Most reactive element.
Really?
So reactive.
Wow.
It can even set other elements on fire.
Oh, my goodness.
Yeah.
Okay, so you have the alkali metals, the givers,
Right.
the halogens,
The taker.
the takers.
Yep.
What happens when they get together?
Fireworks.
Yep.
Sometimes, literally, they react really easily to form salts,
Oh,
like the table salt we use every day.
right. Sodium chloride.
Sodium chloride, exactly.
Just a phone.
So it's proof that even the most dramatic elements
Yeah.
can find balance.
And fine balance. I like that.
Yeah.
Okay, now let's talk about the cool kids in the back.
Yes.
The noble gases.
The noble gases.
These guys just seem so chill.
They are. They're the introverts.
Okay.
They're perfectly content with their full electron shells.
Okay.
They rarely react with anything.
So they're just like
They're like the Zen masters of the periodic table.
Yeah.
Just chilling.
chilling in their electron cloud.
Exactly.
Okay, no deep dive is complete
Oh.
without a little history.
Absolutely.
So tell me, how did this detective's toolkit,
Yeah, it's a fascinating story.
Yeah.
It all started with Dmitry Mendeleev.
Dmitry Mendeleev?
Yeah.
Okay.
Back in 1869.
Wow.
He arranged the elements by atomic mass, and he started to notice these repeating patterns in their properties.
Okay.
But here's the really crazy thing.
Yeah.
He left gaps for undiscovered elements.
What?
And he even predicted their property.
He was like a chemistry Nostradamus.
He was.
That's wild.
He was way ahead of his time.
Okay, so we went from his version to the one we use today.
So later on, Henry Moseley
Yeah.
figured out that arranging elements by atomic number,
Okay.
not mass,
Gotcha.
made the patterns even clearer.
Okay.
And that's the version we use today.
So it's constantly evolving then.
Absolutely. It's a living document.
That's amazing.
Yeah.
We've covered the structure, the trends, those key groups.
A little bit of history.
A little bit of history.
Yeah.
What an amazing detective's toolkit.
It really is.
Yeah.
And the coolest part is that it helps us understand
Right.
not just what elements are,
Yeah.
but why they behave the way they do.
Why they behave the way they do.
So it's really the key to unlocking the secrets of the universe,
The secrets of the universe.
one element at a time.
Okay, now I have a question for you out there listening.
Yeah?
What if you could discover a new element?
Ooh, that's a good one.
Where would it fit on the table?
Right.
What would its properties be? Think about it.
Yeah.
The periodic table is waiting for its next big reveal.
It is.
Who knows? Maybe it'll be you.
That's right.
Until next time, happy chemistrying.
Happy chemistry.